This lesson is going to focus on the inverse sine function. To start us off, I'd like to write an equation sine of theta equals 1/2. If I was looking around the unit circle, the idea is I would go up to the first spot that would have sine as 1/2. I would write down that that angle happens to be 30 degrees. I would also could write it as pi over 6 if it was in radians. I would then keep going around the unit circle until I would hit it a second time, realize that I could have a second answer of 150 degrees or 5 pi over 6. This doesn't end because the circle can keep going around and around again. I would end up not on 30 degrees, but 390 degrees, which would then be 13 pi over 6. And I could keep going around and around again until I got to here, and that would be 510 degrees, or as we like to call it, 17 pi over 6. This could keep going counterclockwise, around and around we go. However, I could also go backwards around the unit circle. I'm supposed to hit the red key there. I could go backwards around the unit circle, find myself here, which is not 150 degrees, it's the same spot, but it would be negative 210 degrees, also known as negative 7 pi over 6. Keep going clockwise until I hit this spot, which would be negative 330 degrees, or negative 11 pi over 6, and realize this keeps going around and around and around. In all cases, this is not exactly a good thing, because the whole idea of a function is that I should be able to go sine inverse. I should be able to stick in for my x a ratio, and what should come out is an angle, or more specifically, one angle. And I emphasize the one because the whole idea of being a function box is that you're only allowed at most one answer. So having these multiple answers, be it in degrees or radians, isn't going to be helpful whatsoever. So where have I gone wrong? Well, that's why I'm going to look now at using the GeoGebra program and realize if I looked at my sine equation, which is right here, y equals sine of x, I use my horizontal line test. Oops, click on this button right here. If I use my horizontal line test, you'll see that this graph is crossing in numerous spaces. In fact, let's go back and write the equation right there so that when I write sine of theta equals 1/2, I have an answer here and here and here and here and here and here and here, and you get the idea. Pretty much the list of all the points that I had mentioned before. The horizontal line test specifically says that if you have a horizontal line crossing your graph, the inverse of this function will not be a function. And so this is where I run into my issues. What I need to do is somehow pare it down, trim it down. Or more importantly, what we're going to do is what we're going to call it is we're going to restrict the domain. So in order to restrict the domain, let's clear out the screen here. I will adjust accordingly by cutting off the graph appropriately. Let's say maybe I start at 0 and I go to 2 pi. I've cut the graph off, but as you can see, I'm still getting two solutions. If this was my function box and that was my response out, it's not good. We don't want to have two answers. I also want to take into account that between 0 and pi over 2, let's write this down, between 0 and pi over 2, which is also 0 to 90 degrees, I would want those as part of my answers because any right triangle that I draw, once I know that this is 90 degrees here, this only leaves me answers from 0 to 90 degrees as my angle. So whatever I get, I want to include this region right there. So it'll be important that I restrict it. So not only do I get the positive ratios, which would be, let's clear this out again. Oh, okay. Positive ratios, that's anything above here, because remember my y's in a sine function are ratios, while my x's are my angles. I want to make sure I get all the positives, but I also want to make sure I get all the negative ratios as well. Oops, that was not expected. Oh well. So let's get right to the heart of the matter. If I adjust my restrictions so that it goes from negative pi over 2 to pi over 2, There we go. You'll notice that it will not only pass the horizontal line test, but I will also have all my negative ratios and my positive ratios covered. So what does this mean in the big picture? All right, here we go. Oh, let's clear that all out. If I were to write on this side, y equals sine of x, because I have here inside goes my angles, and out comes my ratios. Right now, normally my domain would be all reals, and my range would be from -1 to 1. Unfortunately, having my domain of all reals is not going to be useful because that would not allow my inverse to be a function. So when I come over to here, in order to force it to produce only one angle given one ratio, I'm going to have to change this domain, or not really change it, but I'm going to use a restricted domain going from -π/2 to π/2. And so what was my restricted domain will now be the answers that I get out as my range for my sine inverse function. Of course, my ratios that were my range for the sine function would now be what I would input into my sine inverse. What does that graph look like? Well, I'm going to clear this all out one more time. There's my key. There we go. Clear it out. Let's pop up the g of x function. And we'll turn off the horizontal line test. And again, let's take a look at what we actually have in front of us. We have here a reflection with respect to the identity function. The identity function, of course, being y equals x. That's what the red graph is. It shares many similar features. It will involve the same width this way would be the height this way. In fact, let's just get to the heart of the matter. And this is where it gets a little confusing. Right now, these are set up to be angles for the green graph. These are set up to be ratios for the green graph. If I would focus solely on my inverse, come on, off we go. Well, we're not seeming to be turning it off, so let's try this again. There we go. This doesn't make any sense at this point to have π/2 this way. So in fact, I should probably do the following. Nope, I don't want that. There we go. We really should be changing the x-axis to 1s, the y-axis to π/2s, and now this is going to make more sense to say, since these are my ratios, I'm going to go from -1 to 1, and my angles, which are here, are going to go from -π/2 to π/2. Looking at this graph, besides the fact that we've already established that the domain, again, is from -1 to 1, and the range goes from -π/2 to π/2, which I think you should also keep in mind is the same as -90 degrees to 90 degrees. You'll notice that there is symmetry with respect to the origin. Which means this is an odd function. The other thing you should also pay close attention to is that since the sine function did not have any asymptotes, we would also say there are no asymptotes as well for this particular graph. The biggest disadvantage to a sine function is the fact that you are blocked to get an answer back more than 90 degrees. And the reason that's a big deal, let's clear this out, is I'm going to draw a particular triangle that later on, if we would use, let's say, the law of sines, and we got it down, and we were trying to figure out this angle here, hypothetically, if it would have said sine of theta happened to be, our work was 1/2, by doing the sine inverse of 1/2, the only angle would come back would be 30 degrees, or pi over 6. But since it's probably a triangle, we'll focus on the 30 degrees. This, in my drawing, is definitely not 30 degrees. This may have been 150 degrees. The problem is your function box will never give you 150. It's just not one of the options. It's going to be up to you to figure out that what you meant was 150 degrees and not the 30-degree angle. So when you're working with sine inverses, there's always a concern that there may have been another answer or two that would have worked for this particular problem. So keep that in mind as you're doing this. Otherwise, that's the basis of the sine inverse function and why we restrict the domain. Next up will be inverse cosine and inverse tangent.